We will begin talking about the topic-related classes and how we would be using those in Java. But before that, we need to differentiate between two, let's say, paradigms that exist in networking. Most likely you have seen some form of description of the network stack. So typical ways to describe that would be the old SI model, which I will not go over today. I will, however, talk about a simplification that we usually refer to it as the TCP/IP model. So the TCP/IP model is essentially the idea that I can stack layers of protocols. So each of those layers that are stacked are related to how abstract or how close to the operating system or how close to the physical world I am. So if you go downward, you are essentially getting closer to the physical world. Meaning, for instance, that if you are using like a Wi-Fi connection, the media that we are using is the air itself, right? And obviously there are ways in which I would modulate, create some waves that could be transmitted over the air. Same idea happens when you are using cable network. So if you have actual cables, like a plugged-in cable that goes over some form of hub or switch, and that would connect, that would go over some routers as well, and that would connect you to all other possible machines that you can connect against. So this is the general idea that I want to emphasize. This would be one extreme. The other extreme would be the application layer. So the application layer would be essentially where my high-level protocols would be running. And the best example that I can give you is the HTTP protocol. So the HTTP protocol is going to be one example of a protocol that would live in the application layer. These two layers here in the middle, these would be where the TCP/IP stack actually touch. So here I would have what we call the network layer. That would be the regular referred to as the layer 3 layer. 3, because we usually use the numbering of the OSI model. So in the OSI model, the network layer would be the third one from the bottom to the top, right? So this is also commonly referred to as layer 3 layer. And we would have the transport layers. So the best example, the most important example that we would have in the network layer would be of protocols would be the IP protocol. And by protocol, I mean just an agreed upon set of rules that would be used between parties, between, let's say, computers A and B to communicate. So because these are previously agreed upon, then A and B, when A wants to send something to B, B is going to be prepared for whatever kind of message that it would receive from A. So that's what we usually refer to as a protocol. And this is really just an algorithm that is that now instead of thinking about a single party, you have multiple parties and you have parties communicating, you have machines communicating, exchanging messages from A to B or from B to A, and so on. Is that the idea of protocol is clear to everybody? Yeah. So as I said, IP or internet protocol is the most important protocol and the best example of a network layer protocol that I would have. It is specified in the TCP/IP model. You have versions, right? The most popular version that you would have would be IPv4 and v6. We still use IPv4 a lot. So IPv6 is nowadays still coexisting with IPv4, right? The formats, the typical ways in which I would represent addresses that can be used to reach machines in an IP network would be, for IPv4, would be something like this. So 4 numbers where each number is essentially an octet, meaning that each number would vary from 0 to 255. because you have 8 bits, right? It's an octet for each of those, and we typically represent these in base 10 and then separated by dots. So that would be an example of an IPv4 address. Now, the most important transport protocols are actually two. We have TCP and we have UDP. Forgot to mention that IP, the main reason why IP exists is to essentially route the packages from one endpoint to another. So it provides the ability to use the addresses. So the addresses are essentially a way for you to represent the machines in the network, and a way for you to route, to send the messages and create a path that can arrive at some location. So that's the main goal and the main purpose of IP. The transport protocols, they would abstract a higher level idea of a sort of a channel, a sort of a pipe that would be created among the endpoints, and the TCP protocol is going to be an example of a protocol that provides something called a connection. So connection in the TCP IP world has a very precise meaning. Connection means that I have a virtual channel that is being established every time that two or more parties are communicating, and that channel would allow me to have guarantees. What kind of guarantee? The most important one would be a guarantee that my package, my message would be delivered. So when I use TCP, I have the guarantee that my package would be delivered. And the way that this works is essentially just by every time that A sends message to B, B needs to confirm the receipt of that message. Not necessarily right away, but eventually after some iterations, after some packages are sent, the receiving party would need to reply back and acknowledge that the package has been received, right? So that's what we usually call a connection. A connection has a establishing phase. It also has a disconnect phase. I'm not detailing. There's a lot of things here that I could detail, but I'm really trying to just give an overview, especially for those of you who are not so fresh on the networking concepts. And this is really just the minimum that we need to understand for us to have a working piece of code running over the network, right? So as I said, if I use TCP, I have these delivery guarantee. If I use UDP, I don't have any guarantees whatsoever. That's the main reason why UDP is created, just to be as lightweight as possible. Obviously, all these guarantees, it comes with a cost, and the cost is an overhead. So my packages would be larger, so I am exchanging more data. I have a connection phase, I have a disconnect phase. So this creates an overhead, also sort of a delay that needs to happen before the data is actually exchanged, right? So if I go with UDP, even though I don't have those stages, I still am able to send and receive data, right? So the difference is just that I don't have these guarantees. So even though it being more lightweight, I am giving away on these sometimes precious guarantee that I would want to have. So HTTP would be one example of protocol, high-level protocol that would be using TCP. And the best example that I can give you for UDP would be the DNS. So the DNS is the protocol that that allows us to provide a host name like Google.com, and this gets translated into an actual IP address. So I'm making up the number here, but imagine that this is actually some valid IP in the Google network. So these would essentially be a conversion, a translation from one URL, one host name, to an IP address. Same idea can be done with IPv6, and there are also some other lookup messages that I can use on DNS, but this is by far the most common one, which is, as I said, just a conversion from one human readable host name to an IP address that you obviously will not be memorizing, and that allows essentially any time that you need to reach some physical some service, some host name, that allows you to just refer to that given service or website or name as a single host name, and you don't even need to bother about that. But under the hood, the messages are actually being exchanged with that information. So it's necessary for me to have an IP address for me to be able to transmit a package. But this can be done, as I said, fairly transparently because of DNS. So DNS is one example of a protocol that is transported via UDP. The reason for that is because you don't really need all that reliability when you are doing this lookup. Like if you do a query against a DNS server and you don't get a response, you can just do the same, just repeat the same query, and you do that as many times as you want, or as many times as you need, right? So this is essentially a fairly robust mechanism that you can use, and it doesn't come with a high price to be paid if you don't get a response. So there's not really a lot of need in terms of having the DNS using a more robust connection-based connection. Any questions so far? I know I'm going super fast, especially for those of you who are not very familiar with network concepts, but I hope that you're at least picking up the main concept that I want you to pick here, which is what TCP and UDP means. So what I really want you to focus on for our understanding here is roughly how addressing works, and then how TCP and UDP works. Another concept that is important is the concept of port. So port is a way for us to have different access points, different points that I would access in the same machine. So when I have, imagine two machines communicating, it might happen that you have multiple programs running still in those two machines, right? So you can think of it as one machine acting as a server and the other machine as acting as multiple clients. I can have that, but I do need to somehow multiplex the connection between machines. The way that I do that is via the concept of ports, and these ports are essentially just a number that specifies which entry point I am using in that given machine. The port would exist in both ends. So one port in one end would be connected to one port in another end. And usually there's a related concept that we call a socket. The socket is an operating system concept that this is the socket class that is somehow related to that. But what I'm telling you right now is the concept that we usually see in network operating systems that represents the set of two hosts. So two IP addresses, for instance, or two host names, and two ports. So at the two ends, you would have two ports that don't have to be related in any way to each other. So I can have like a port 10,000 on one end and port 80 on another end. So the only relationship that would exist is that we usually use standard ports for the server side ports, because that makes our life easier, and it's fairly a good convention to not have to specify a port when you are connecting against a server. So for instance, when you are using your browser, by default, you would be using the ports 80 and 443. And the reason for that is because we have set the standard for HTTP and HTTPS, which are associated with those specific server-side ports. Okay, so that's essentially a convention. Obviously, I can specify a different port if I need. And by the way, if you want to do that on the browser itself, you can just come here to address bar and then use something like after the host name, you just put column and then the number of the port that you want. So this would be the way that you would specify a custom port other than the 80 or the 443, right? When we have HTTPS,
the default would be 443. When you have HTTP, the default would be 80. So if I don't specify, it just goes with the default. Okay, this will not work. This is just for me to show you the because actually I believe it doesn't, right? Let's see. Yeah, it probably doesn't. I would need to have a server set up on that port for that to work, right? So if I do, then these would end with an HTTP service, right? Does that make sense? All right. So after this super crazy fast introduction on networking, let me cancel this thing here. I want to now focus on our Java API. The way that we would first explore connectivity would be via TCP-based connections. As I said, in a TCP world, I would have the guarantee that my packages would be delivered, right? Which is good. If I don't mind about the overhead that I would have. So if I want to have that kind of functionality in Java, I would want to use the socket class associated with the server socket class. So these would be the two kind of classes that I would want to instantiate, and that would allow me to create either a server side socket or a regular client socket. Another related concept is the server client paradigm. So the server client paradigm just means that you would, for a typical network setup or network program to work, you would have first a server launched, and after that, you would have one or more clients connecting against the server. So the server is a sort of a hub that needs to be up, needs to be alive before the client would actually connect. And as I said before, typically we set some standard ports for the server, and the client, we don't worry so much. So then usually the operating system chooses some port itself, and that can be done automatically for us. So usually don't need to bother. Okay, is that clear? All right, so how to use those two classes, right? Let me shift to my IDE now. Yeah, I'm sharing. So here I have our first example, two classes, Echo client and Echo server. Let's make this bigger, make your life easier. So I have Echo client and Echo server, right? So the idea is that, as the name implies, I want to implement an Echo service. Echo is just something that repeats whatever I say, right? So the functionality of this program would be to send some string over the network, from the client to the server. The server would receive that string, that message, and then it would just send the same string back to you. Okay, so just the idea of an echo, right? Perhaps not super useful, but actually this is the idea behind the most used utility in networking called ping. So the ping actually uses the same idea, not with TCP, that would be another protocol, but still that's the idea. It would send a message to some machine, and then it would want to receive back a response from that initial message that you sent, right? That's the idea. Again, not ping doesn't use TCP, remember that, okay? But this is just to illustrate the idea. So what are we doing here? Let's go over our main method here. I am reading from my arguments, and I would expect to receive a host name followed by a port number, right? Why? Is that something that I really need? So you are the client. So you are the end that is connecting against the server, right? Do I need to know the server address or host name? Yes, you do need to know that, right? So you either hard code that or you specify that, so you get that from some formal input. In this case, we are getting from the command line argument. So the first argument is the host name, the second is the port number. So remember that I mentioned about the idea of the port. The port, again, this is not a standard service that exists. So then I could perhaps come up with a default port for that. But in this case, we are not doing that. So then I am requiring you to specify a port, right? So if that would actually be a more standardized protocol, perhaps I could just go with a default port. So that's quite actually standard to see, right? Again, for me, who is the client, from the client perspective, to connect against the server, I would need to specify the port, okay? I just check for that, right? I save the host name from the arg. I save the port number, again, from the arg. And then assuming if I reach this point here, obviously this didn't happen, right? So this here is not true. So so then I can just print a message saying that I am connecting against server name and port. And then we have the main functionality implemented here. So here I have a socket class being instantiated. The way that I'm doing that is by calling this constructor here, where I specify the host name and the port itself. So this is one of the constructors that I can use from socket, and this is most likely the most convenient one because you're already specifying pretty much everything that you need to connect to allow the operating system to do all these magic here, the TCP/IP and networking stack to be utilized, and all the related protocols to be used to allow this message to be encoded and transmitted to the end server. Okay. So here I am. One thing that is interesting to mention as well, and I mentioned that briefly before, is that when you want to communicate over the network in Java, typically you would use the IOStream API. So here we are just using something that is actually familiar to us. I am using a kind of writer object, right, as a way for me to provide a sort of an output. So recall that we have the readers and writers and the input and output stream, right, from the IOStream API. So I can just create a print writer class, and I can use my instance of my sockets to get an output stream for the creation of that writer. Right? So here what I'm doing is essentially just calling a method on the instance of the socket that I created, and that would return to me a stream object, and that stream object would be used for the creation of my writer. So far, so good. Okay, so now I have this out object that allows me to write. And every time that I write, I would be essentially sending messages to the other end. As simple as that, right? So the writer here allows me to send messages. The other way would be for me to receive messages from my server, because I am the client. So I would be receiving from the server messages as well. And the way that I am going to do that is by using a reader object. So again, same idea. Here I am instantiating a buffered reader. I am passing, I am calling the dot get input stream. Why is it that I am calling this class, this constructor here? Who remembers input stream reader? Why do I need that?
Make a between like the input streams and the readers.
Right. So every time that you are receiving an input or output stream, and you actually want to have access to a reader or a writer, the equivalent, you actually need to use this compatibility class, right? So it's a simple way that Java allows you to create, in this case, a reader from using an input stream. So these would return an input stream. But then these here would require a reader. So obviously, buffered reader, actually, perhaps not obviously, but if you check the constructor, you'll see that The expected format would be an input stream. So you need to, sorry, it's a reader. So you need to make that compatible, right? Any questions on that? So with only those two lines, I have pretty much set up everything that I need to exchange messages between these two machines. As simple as that, right? So if you understand how IO stream works, you understand how networking works. Okay. This is just a buffered reader to get from system input, right? So in this case, because of the way that this program would work, I would be required to type some message, and that message would be the thing that would be sent over the network, right? So then I am just setting up that stdin to read from my standard input. Here I have a loop that would go over, and all that is in the resource block here, right? Why? Auto closes it. Yeah, I don't mind. I don't need to worry about closing all those streams, right? So it's convenient. It makes the code more cleaner, and less prone to us forgetting to actually close those streams and creating issues to the operating system. And then finally, here I have the main loop, which is I am just creating a string object, and then I am going over this condition here that is just calling read line. So when I call read line, I would be essentially getting the input that I have typed, right? And then these would be transmitted to my server just by making use of the print line functionality of my writer. Okay. Easy, right? That clear? Yep. All right. Then I'm doing the same thing here. I'm reading from my standard input, right? And then I'm just using that as my output. Actually, oh no, sorry. Here I'm reading from the response that I get from the server, right? So that would be the response that I get from the server, right? That in reader that I have, right? Any questions? All right, so just treating exceptions, right? So unknown host would be an exception, IO exception, just treating that, printing a message and leaving, and that's pretty much it from the client side. Right, so this is the code that implements the client side of this echo service that would essentially just get whatever I type in my keyboard, send it over the network to the server. The server would receive, just copy that and send it back to me, and then I would print whatever I got from the server, which should be the same thing that I typed, right? So if everything works, actually, I expect to type something and then receive the response from the server precisely with the same message. Okay. Now let's check the server code. So the server here, you would see something very similar. I have my main method. I am checking for my my arguments. In this case here, I don't need to specify a host because it's kind of implicit that the server itself would be the host, right? So this is not always so straightforward because it's actually possible for a machine to have more than one host name or more than one IP address. In those cases, typically, and that's depending on the API and how you set up things, typically what would happen is that your server would actually be listening on multiple entry points, on multiple host names or multiple IP addresses. So then if the message comes directed with the return value to any of those valid host names or host IP addresses, then that should be good, right? This is not universal. So it might actually happen that your server is listening on one specific host name or one specific IP address, or even a set of those, but not all. Okay, but it's important that you at least understand that all these are playing somehow a role on the what's actually going to happen in the server side, right? So in this case here, I opted to not get these information on the host name. So I'm just going with the default. The default obviously would be the host name itself, which we usually refer to as the local host, right? And then I need to specify the port number. Again, here, if that would be a standard service, a standard protocol, high-level protocol, perhaps you would have a default port, and then we wouldn't even need to specify the port. But in this case, because I am specifying, let's say, custom port, then I need to align whatever port that I choose on the client side with the server side, right? Because the client is trying to reach my server at that specific port. So if I don't choose at my server side the same port number, what's going to happen is that these would not match, right? So the message would not actually arrive at the right entry point in my server. All right? Does that make sense? All right, so same as before, I'm just checking if that the length of the argument is okay, right? So then I'm parsing the port number. I am printing a message, and then let's see here the setup of my resources, right? So now there's a little bit of a difference here. I am using a server socket instead of a socket. So the socket was used at the client side. Now I'm using a server socket. What's the main difference between a server socket and a socket? With a server socket, what I can do is set up a so I can initiate the process that would put my server in the listening state. The listening state means that my server would be ready to accept connections, right? So this is a setup that needs to happen before any client is able to connect against my server. Okay, so the way that I do that is by calling .accept. .accept would create a socket object that would essentially tie the two ends in the network. So it would tie the client side with the server side, right? The way that you see this here, there's only one limitation, which is I can only have one pair of server and client. I cannot have multiple clients connecting against my one server. Yet there are ways to actually do that, right? And we will show that. But this first example here, we still don't have that. So I would have just one pair, one client and one server, and they would be able to communicate. They would be able to establish this connection, right? So this is essentially the main difference. The rest is pretty much the same, right? So if you observe here, I have precisely the same thing, right? The only difference is that in this case means that I'm getting from the client, from the server perspective. In is receiving a message from the client, and out means I am sending the message back to the client. Okay, so just the inverse, right? Just the other way. Any question on that resource part?
So using socket means we are using TCP, right?
Yes. So far, we are always using TCP, right? So we are talking about a connection-based exchange of packages, which means that every time that I send something, I would have a sort of a guarantee that these would really be delivered. Okay.
So client and server both need to listen on the same port.
So the client doesn't listen. The server is the one that listens. So then it kind of keeps waiting for the client to come and send a message, right? So it's always these sequence. First, the server is put in the listen state, and then it's essentially waiting for one client to connect.
So in case when we are running this, if let's say the accept happens after the connection request was sent
then it doesn't work.
It doesn't work.
Doesn't work. You first need the server set up, then the client would connect against the server. We can even try to show that these would not work. You need to have a server listening before the client would go and connect to the server.
Where are we ensuring that this client side happens first?
In the code, nowhere. So these would,
Okay.
yeah,
We're
we need to
executing-
run.
Okay.
So these are two pieces of software, right? So I would run the server first, and then I would run the client next, right?
Yeah.
In this case here, I would run the same machine, but you can actually do that over the network. That would be the same thing.
I get it.
Okay. Good. So here, there's the same thing, right? So I'm reading from input, actually not precisely the same thing. Sorry, I'm getting the message from the network, and then I'm just sending it back to my client. Right? Is that clear? Who got it? Okay. You are free, welcome to ask. So if you don't get, just say, so read line will just read one line from my input stream, right? Which is just that string that is associated with the network connection. So at this point here, the network connection is set up already, right? That was done way back here, right? By the way, this is blocking. So until the connection is established, nothing would continue. Okay, this is a blocking operation. All right, an operation that needs to finish before anything goes.
So this whole program only echo once and then.
It's no, it's in a while loop, right? So
So we are reading like the server is sending us like the.
one line at a time.
Line at a time, and we are like sending it again to this one.
Yes, right. Yeah, if that would not be a while loop, if I would just run it one time, then this would be just one exchange of messages. But because here I'm on a while, and in the client also have a while loop, right? So then this would go until I get null from readline. Okay. And that's it. That's all that this code is doing. Just handling exception here, right? That's it. Let's see that working, right? So let me first, actually, let me do it the wrong way first, and then we do the right way first. So the wrong way would be to do what? To launch the client, right? So launch the Echo client first, and then you see that this already gave me, actually, this is not related to the error that I want to show. Hold on. I'm getting this thing. Yeah. So this is the error that I would expect. So I am not capable of completing my connection. Okay. Why? Server is not up. I need first to put the server on the listen mode or state, right? So then my client can connect against it. So let's go launch the server. Oh, by the way, here I didn't show, but I did previously set the host name and port. Okay, these needs to match, right? And in this case, because my server and my client is in the same machine, so then I'm just using localhost. But if you would actually have that happening over the network, you would need to specify the IP address or the host name of the server, whatever it is.
So originally the random number, right? But then when we are actually connecting.
So it cannot be random with respect to setting the server side port. It can be random. The client side can be completely random, right? And usually is random. It's just greater than 1024, but it is a randomly chosen number.
No, I was just saying it should be over 1023.
Yes, because there's this convention that anything below 1024 would require super user privileges. So you cannot
I think
actually.
they are restricted for like specific one.
Yeah. That's the reason, right? Because you don't want to have services not runnable by the super user on these low ports. So just a security measure, right? Clear?
So server side also means when there's this 1, 2, 3, 4, 5 socket,
This is the port.
the port. sorry.
Yeah.
So.
So I chose these, I can choose whatever, right? So actually, the maximum is 65, 535. But anything below that can be, is a valid. And also, if you are not the super user, you need to choose higher than 1024 as well.
And is that possible that this port at the server side is already getting used somewhere else?
Yes, it is possible. It is possible. So then what do we do?
There will be a error there? No.
So then what would happen is, so imagine that you have a service running in the server at that port, right? And then you connect using this approach here. You now have two programs talking different protocols, right? So these would, at some point, this would not work. You might even, because sometimes we do use a lot of default ways to communicate. You might even let it see it like going for some steps, but then eventually it would fail because there's the mismatch in the protocols. Okay, all right, let's see that now working, right? As I said, I have set up the client with that information, and I also did set up the server. Let me show you. Server, we don't have the host name. We do have the port. So here you see that the port is matching, right? Okay. Let me run the server. So now my server is up. Next, I would launch my client here. And then you would see that it no longer throws an error, right? And if I say, hey, it would receive back the hey from the server, right? Not super interesting, but definitely more interesting things to do over the network, but it's more like a proof of concept, right? That it does work. Okay. What else can we show about this? Let's show the mismatch of the port. If I have my server running on 1, 2, 3, 4, 4. And my client trying to connect on the previous port, this should not work, right? And this doesn't work. Okay, so essentially my server needs to be listening on that specific port that my client would try to connect. Otherwise, it would not work. All clear? Now let's see our second example. Let's at least begin talking about the second example here. What we have is a slightly more involved example, not by much, but still here I have a, let me tell you first what this does. So this would be exchange of messages where my server would expect to see a specific message, and then it would act based on that. So it would expect a given message. If it gets that message, then it would respond. And this is essentially just to show this sort of a game. I think there's a name to that game, knock knock, whatever. So you just like let me show you the server. Oh, we actually have a protocol, I believe, right? Yeah, we have a protocol that implements that. So you have you expect to see the server telling the specific strings. So the server would first say knock knock, who's there? Then you would say turnip. The client would say turnip. Then the server would say turnip the heat. It's called in here. And all that's a very interesting thing. So let me, we don't have a lot of time to go over the code, so I'll just show that running. Then next lecture, we go over that code, okay? I have the server, I have the client. I believe I have set the Yeah, I have set it up already. So I already set up the host name and the port and all that. So who's there? So I would not put the question mark just to show that I'm gonna get it there. So you are expect to precisely say that, putting the question mark. There. Then it shows the next message, turnip. And you go and say turnip who? Turnip who? Turn the heat. Let's go in here. Want another? Yeah. One more. Knock, knock. Who's there? Little old lady. Little old lady who? I didn't know you could yodel. Want another? That's it. All right. Any questions on that? It's just showing the workings of the system, right?
That is implemented there is just a way of the communication between the client and the server. It's nothing related to the standard protocol.
It's a protocol that we invented, right? And in the homework, actually, there's a protocol that I want you to implement. So it's kind of the same idea. And in the we have a class that implements that. So you would see that you have these states here. You have the waiting, you have the send knock knock, send clue. So you have these states, right? Because it's a sequential protocol. So you just go from state 1 to state 2 to 3. If you fail some of those, you go back to the first one, right? Until you reach the last one. Okay. All right, so we will continue next time from that protocol and that implementation, and then the multi-thread version of that server, and then the UDP implementation, and then we would be done with network. Okay. All right, have a good day.